Let us discuss about divide and conquer. In a divide and conquer, we will study about recursion, then recurrence relation, then recurrence relation solving. Suppose we have to find out factorial of 6. As we have studied in mathematics, factorial of 6 is nothing but 5 into factorial of 6 into factorial of 5, right? And factorial of 5 is nothing but 5 into factorial of 4. Factorial of 4 is 4 factorial of 3, and so on. Right. We know that factorial of 1 is 1. So 1 will be returned to f of 1. 2 into 1 is nothing but f2, which will be returned to f of 2. 3 into 2 is nothing but 6, and this value will be returned to f of 3. 6 into 4 is 24, and 24 will be returned to f of 4. And 5 into 24 is 120. 120 will be returned to f of 5. 6 into 120 is 720, and this value will be returned to factorial of 6. So factorial of 6 is 720. We calculated this factorial of 6 by calling the same function again and again. To find the factorial of 6, we need to find the factorial of 5. Means we called the factorial of 5 to find the factorial of 6. In order to find the factorial of 5, we required factorial of 4. So we called the f of 4. To find the factorial of 4, we required factorial of 3. So we called f of 3. And so on, we called f of 1. This is the termination condition. F of 1 is termination this is termination, right? So recursion is nothing but calling the same function again and again to solve a problem. Calling same function again and again to solve a problem. To solve a problem. In our example, the problem is to find the factorial of 6, and factorial is a function, and 6 is its parameter. So factorial of 6 follow the behavior of the recursion. This is nothing but recursion. Factorial 6 will call the factorial 5, factorial 5 will call factorial 4, factorial of 4 will call factorial of 3, factorial of 3 will call factorial of 2, factorial of 2 will call factorial of 1. So factorial of 1 will be solved first. Factorial of 1 is nothing but 1. The 2 into 1 is 2, and this 2 is returned to factorial of 2 because it was called previously. And 3 into 2 is 6, and this 6 will be returned to f of 3. So this is the whole concept of recursion, right? Recursive programs require stacks. Recursive function calls are stored in the stack. Alright. We calculated the factorial of 6, right? To find the factorial of 6, we required factorial of 5. So factorial of 6 will be stored in the stack. F of 6 is stored in the stack. To find the factorial of 6, we require a factorial of 5. So f of 6 will call f of 5. F of 6 will call f of 5. Meanwhile, f of 6 will wait in the stack. Alright. F of 5 will call f of 4, as we have seen in our example. F of 5 is calling f of 4, and f of 4 will call f of 3. F of 3 will call f of 2, and so on. F of 1 is called, right? So these are the function calls. How many function calls we have? 6. 1, 2, 3, 4, 5, 6. The number of function calls equal to 6. Now, as we know, stack follows last in first out property, or we can say first in last out. Means the element which is inserted in the stack first is to be popped out last, or the element which is inserted last will be popped out first, right? So f of 1 will be popped out first, and f of 6 will be f of 6 is called first, right? As soon as f of 1 perform its execution, since it is a termination condition in our example, so it will be popped out first and return the value to f of 2. As soon as f of 2 completed its execution, it will be popped out of the stack and return the value to f of 3. F of 3 will perform its execution and pop out and return the value to f of 4. Similarly, f of 4 is popped out and return the value to f of 5, and f of 5 is popped out and return the value to f of 6. And finally, f of 6 will perform its execution and popped out at last, right? F of 6 is called first and is popped out at the last. F of 1 is called last and popped out first. This is the first in last out order and last in first out order, right? So how many function calls we have? 6. So how many stack units are required? How many stack units? 1, 2, 3, 4, 5, 6. So 6 stack units are required, right? This is the whole concept of recursion. The basic definition: recursion is nothing but the function. Recursion means the calling the function again and again to solve a particular problem. And all the recursive function calls are stored in the stack, and stack follow the last in first out order or first in last out order. And number of stack units required to solve a recursive program depends on the program. In our example, the stack units are 6. Number of stack units are 6, and each function call is stored in the stack, right? Now let us discuss some advantages or disadvantages about the recursion. See, before coming to advantages or disadvantages, let me draw a recursive program of a factorial of, right? This is the program or algorithm to perform the to find the factorial of n. All right, this is called the termination condition. If it is an algorithm, it should terminate. So every algorithm should have a termination condition. Sorry, every algorithm should have a termination condition. If it do not have a termination condition, it may go in the infinite loop, right? And similarly, the algorithm should given some output, right? So in the recursive program, we have two parts. The one is terminating part, and the second one is else part, right? So this is the program to find the factorial of n, right? As you can see, this program has finite steps and it is very easy to write. How? Let me just take an example. We need to find the factorial of 6, right? N equals to 6. Let me just run this program. Is n equals to 1? N equal to 1 means 6 equal to 1. Condition fail. Come to the else part. 6 into factorial of n minus 1 means 5. This will call this function, right? Now n is nothing but 5, right? 5 equal to 1? No, condition false. Come to the else part. 5 into factorial of 4, right? This will call this function. Now n equals to 4? No. Sorry, n equals to 4? Yes. If n equals to 1 means 4 equal to 1? No, condition false. Again, come to the else part. 4 means n into factorial of n minus 1 means 4 into fact of 3, right? Now n becomes 3. 3 equal to 1? No, condition false. Come to the else part. 3 into fact of 2, factorial of 2. Now n equals to 2. 2 equal to 1? Condition false. Come to the else part. 2 into factorial of 1. Now n equals to 1. If n equals to 1 means 1 equal to 1, condition true, return 1, means f of 1 is 1. The 2 into f of 2 into 1 is nothing but 2. So this will return to the f of 2, factorial of 2. 3 into 2 is 6. 6 will be written to factorial of 3. 3 into 4 is 12. 12 will be written to the factorial of 4. Right? And so on. I'm sorry. 3 into 2 is nothing but 6. 6 into 4 is